general heritability of this population based on knowing the genotypes and the phenotypes of every individual in the population. So typically we wouldn't know that in most natural populations because it would require an enormous amount of work to go and genotype everyone and take a phenotypic value for those. And so what we're typically going to be looking at is population values and trying some other means of doing it. One way to do it is something called response selection. And this is based on the idea that the response, or the difference between one generation and the next, is equal to the heritability times the difference in selection between the two. So what you do is you go and you take a base population, and here we have a mean phenotype of 10.13, and then you're going to select a certain number of individuals out of that population to reproduce. And so if we put in a selection differential, we can put in differential selection. In this case, what we're going to do is this will basically mean that everybody below this negative 0.2 value, so every phenotype below that, will end up dying or not reproducing anyway, and only those individuals above will reproduce. So that value, whatever survives, that's going to be the selection differential. That's going to show up. I mean, that's this value from this value. So let's hit go and do our selection. So you notice we just chopped off the bottom part of this population, so all those individuals. And we've gotten rid of all of the, in turn, genotypically, all those. So now we have our starting population in 10.13, and after selection, these remaining individuals here, their mean phenotype is 10.37. So 10.37 minus 10.13, right, is going to be 0.24. Right, so this value, 10.37, subtracted from 10.13, we get 0.24. Now, the value in the next generation is going to be here, and this is going to be 10.28. So 10.28 minus 10.13, right, is going to be 0.15. So now we've got 0.15 divided by 0.24, and that gives us a value of 0.63. So our original estimate from knowing all the gene types and phenotypes was 0.66. In this case, our estimated value was 0.63. So what it means is that, you know, that the trait, it has a 63% heritability, and so you can look at that, and you can try this in a number of different cases, but that's what we're looking at.